Good afternoon, Professor. Welcome on behalf of Sairam Institute of Technology, third international conference for ICMSD, and welcome you all on behalf of Sairam Institute of Technology. Okay. This is the session 3. Our chairperson is Mr. Raj Mohan, Dr. T. Raj Mohan, ME PhD from SCS VME University. First, I welcome you, sir. Rajmohan, sir. Rajmohan, sir.
Yes, sir. Thank you, sir. Please.
Hi, yes, sir. Thank you, sir. For the benefit of the authors, I'm reading the profile of Dr. T. Rajmohan. Uh, he has obtained a PhD degree from Sri Sangha SCS VME University in the year of 2013. He has done his ME and BE in Annamalai University. And then Sir worked in various colleges. Since 1998, he has served various colleges until now. He has fields of major scientific interest in order of choice are material processing, tribological behavior of composite material, machining of composite material, optimization techniques, recognition and research profile are reviewer in journals in Elsevier, Springer Nature, and Taylor Francis, recognized as PhD supervisor by SCS VME University, principal investigator, SCS VME University funded minor research projects, project supervisor, UGC sponsored population education program, SCS VME University during the year 2006 and 8, guided 6 PhD scholars and 4 ME scholars of SCS VMB University. Publications, 3 books, 2 book chapters, 50 scientific papers. And then he has drawn funded projects. Details of respective research project facilities currently being completed and undertaken are SCS VMB University. In tune of 50,000 rupees, he has received 4 4 projects. Among the 4 projects, 2 projects, 3 projects he has acted as a principal investigator, and 2 projects as a co-investigator. Number of PhDs completed 6, 1 is underway. This is the short profile of Dr. T. Rajmohan, uh, Professor, CSVM University. I welcome you, sir. I am inviting you for this inaugural address, sir. Please, sir. Sir, the session is yours, sir. If you want to talk to the audience, you can uh, inform the audience about the rules and regulations, all these things, sir. Yes, sir. Ajman, sir.
ഇപ്പോഴാ ഓക്കെ നോ പ്രോബ്ലം.
Rules and presentation, sir.
Yes, sir. There are 6 participants
Sir,
are there.
is it,
So something
so you can
you want
give
to add?
5 minutes for presentation and 5 minutes for presentation and 3 minutes for discussion, sir.
Discussion, sir. Okay, sir. And then shall we call the author, sir?
Okay.
Yes, sir, please.
Yes, we can start. Please.
Okay, sir. Mr. Vijay Bhupati is there? Dr. G. Samusundar? Grace Babu is there? Mandeep Singh is there? Mr. Mandeep Singh?
Yes, sir.
Okay. Could you present, sir, now?
Okay,
Yes,
sir. I will.
I'll cut the share.
Sir, you.
Presentation, you can
Yes, sir. Yes.
present yourself, sir. Yes, sir. Mr. Mandeep Singh?
Yes, sir. Yes, I am coming.
Yes, sir. You can carry on. Carry on. Present your experience.
Sir, wait for a minute.
Take 5 minutes for presentation, sir. 3 minutes for discussion. Please, sir. Carry on, sir.
Sir, is the screen okay? So,
Yeah, visible, sir.
okay.
Visible.
Good afternoon, sir. Respected person and participants. I am Mandeep Singh. Today, going to present a paper named title a review of the mechanical performance of nanoparticle reinforced aluminum matrix nanocomposites with paper ID MATPR D-20-20 So in this presentation, I am going to review the various literature and research work, highlight the impact of nanoscale reinforcements on the mechanical properties of aluminum matrix nanocomposite. So the topic which I will cover in this presentation are as follows. First is the introduction, then the literature view covering the various mechanical properties like hardness, tensile strength, ultimate tensile strength, yield strength, compressive strength, and elongation. Then next will be the analysis in tabular form of literature view, and finally is the conclusion. So then there is an introduction of the nanocomposite using the nanoscale reinforcements. So the nanocomposites are the materials that impact nano-sized particle into the matrix material. So since the last few decades, there is a need for economical, efficient, and lightweight material. So metal matrix nanocomposite have gained a lot of attention and involvement at professional and research levels. So metal matrix nanocomposite, they exhibit a good combination of properties like high strength to weight ratio, low thermal expansion, good wear resistance that are tough to obtain by the monolithic material. So in metal matrix nanocomposite, aluminium, magnesium, and titanium can be used as the base matrix with the different combination of the reinforcements of oxides like silicon oxide, magnesium oxide, alumina, zirconia. And in carbides, we have silicon carbide, titanium carbide, and the other reinforcements like the boronitride and titanium dioxide. So, so the defect-free microstructure, particle, even distribution, and good properties of MMC has made this matrix important. So lightweight ductile aluminium is the most preferred material, most preferred matrix material. And the reinforcement type, size, volume fraction, and hybrid reinforcement, which played a significant role in the progress of the AMNCs. Then, so in this paper, the data is available for the pure and alloyed AMNCs, which have been compiled to assess the nano reinforcement fraction, nano reinforcement size for different mechanical performance, such as hardness, ultimate tensile strength, yield strength, compressive strength, and elongation. So next, in the literature view, we have the we are starting the mechanical properties with the hardness. So what is the hardness? So before starting from hardness, so what are the mechanical properties? So the mechanical properties that involve a reaction to an applied load that determines the range of usefulness of a material. So the most common properties are considered in this review paper. So first is the hardness. So what is the hardness? Hardness is the measure of a material's resistance to localized permanent deformation. Okay. So the nano-sized reinforcement increase the dislocation density in the base matrix as per the proper particle size distribution. So the higher the reinforcement applied to an optimal value, the more constraints on the dislocation moment would be. Hence, the overall hardness of AMNC will increase. So Puvian and other revealed the increased hardness progressively of the AA6061B4C nanocomposites by increasing the nanoparticle volume percentage as 0, 0.5, 1, 1.5, 2, 2.5, and 3. So the strong bonding of aluminium with the boron carbide nanoparticle prevents the dislocation movement, causing the improved hardness to 91 BH Brinell hardness, that is at 2.5 volume percent nanoparticle as opposed to the 40 BHN of the base alloy. Next, zinc and others, that is examine the noteworthy improvement of hardness as 87 Vickers hardness, 100.8 Vickers hardness, and 128.6 Vickers hardness with increase in the 0, 2, and 3 weight percent silicon dioxide nanoparticle respectively in the AMNCs. So the strong interfacial bonding between the nanoparticles and the matrix give the apparent wettability and the uniformity of nanoparticle in the matrix, which was countable for the hardness of the AMNCs. Then next we have Suresh and others reinforce the alumina and silicon carbide nano reinforcement mixture in the AA7075 matrix alloy. The 1 weight percent addition of magnesium has been added to increase the wettability and the nano hybrid reinforcements in the aluminum matrix alloy, which resulted in the excellent fusion and uniform blending and resulted in increase the hardness to 110 Brinell hardness at 4 weight percent when compared with the base alloy of 90 Brinell hardness number. So here is a figure which explains itself that as the weight percentage of nano reinforcement is increasing, the overall hardness is also increasing. Then next we have the Zhang and others fabricated the A355 aluminum silicon alloy reinforced with 1 volume percent of graphite nanosheets and found the 115.1% higher hardness than that of the base alloy. The graphite nanosheets refined the grain size more homogeneously, leading to an increased dislocation, organ strengthening mechanism, and the consequence of thermal mismatch. The hardness was enhanced to 174 point Vickers hardness of aluminium graphite nanosheets nano composite in contrast to the 81.2 Vickers hardness of base matrix. Then we have the mechanical property, second mechanical property, that is the ultimate tensile strength. So what is the ultimate tensile strength? It is the ability of a material to resist the tearing due to tension. That is, it is also measured in pascals or it has unit Newton per meter square. So it is investigated from the published studies that a UTS of the AMNC has been strengthened by the nano reinforcements. The tight intermetallic bonding causes the wettability
So conclude
and the
yourself, sir.
sorry,
Dear
sir.
Mandeep, sir, conclude yourself, sir. Yes, chairperson advised 5 minutes for presentation. Can you conclude, sir?
Sir, it is a reviewed paper, so I have reviewed from the different.
No, no, 5 minutes for presentation, sir. Let others also to do
Okay,
present.
let me wind up. Okay, let
Yes, please, please. Thank you.
thank you, sir. So Guglian and indicated the 125% increase in ultimate tensile strength of the AA6061 boron carbide nanocomposite in contrast to the alloy. The boron carbide nanoparticle improved the ultimate tensile strength at 0, 1, 1.5, 2 volume percent. But the aforementioned beneficial effect of adding nanoparticle weakens the AMNC, which diminishes the UTS. It is due to the high dislocation density and the interaction of the dislocation of the ultra high nanoparticles. So the nanoparticle at the grain boundary interior showing the homogeneous dispersion, which improve the UTS of the AMNC. Then the next I'll skip. Then coming to the yield strength. So what is the yield strength? Is defined as the maximum stress that a solid material can withstand when it is deformed within its elastic limit, or it can be defined as the stress at a point where the stress strain curve deviates from proportionally. That is the yield strength of the material. So here Lee and others made use of TIN nano reinforcement particle by varying the weight percentage of 1, 2, 3, and 4 in the AL2024 alloy. The increasing titanium nitride content improved the yield strength to 3% and the volume recorded at 2 weight percent, that is 730 megapascal, which is was 185% higher than the baseline. So the reason for is the necking regions and some big pores were seen at 4 to 8% nanoparticle, which become the source of the crack and show no yield action due to the non-occurrence of the deformation of Al2024 titanium nanocomposites. Then next mechanical property we have the compressive strength. So what is the compressive strength? The maximum amount of compressive stress that a material can withstand before it breaks or friction. So Izardpur and others studied the zero point 0.4 and zero point 0.8 and 1.28% of aluminum oxide
Sir,
nanoparticle in the.
sir, conclude yourself, sir, please.
Okay. So in the conclusion and future scope, we have that is the outcome of the study will provide a better understanding of the analysis of various nano reinforcing material on the properties of AMNC. Therefore, there is a huge scope for the selection of proper combination of reinforcing material for the fabrication of AMNC. Although the metal matrix grain size is one of the most basic parameter to determine the mechanical properties of the AMNCs. Adequate measurements for the grain size have not been conducted in many previous studies. Then second, that is the increment of properties for AMNC that depend upon the distribution of nano reinforcement phases, interfacial interaction between the aluminum matrix and nano reinforcing material, and the structural integrity of AMNC. Being a nanostructural material and very low concentration used for the fabrication of AMNCs, the uniform distribution of nano reinforcement material in the base matrix is a significant challenge to the material scientists. So there is a huge difference between the strength and stiffness of nano reinforcing material. Strong interfacial bonding between the nano reinforcing and the aluminum matrix can enable effective stress transfer between the nano reinforcement material and relatively weak alloy matrix. So more search in these areas are encouraged to tailor the properties of AMNCs. So last conclusion is that is we can use hybrid AMNCs instead of mono AMNCs. That is hybrid AMNC can be prepared by using properties of more than one nano reinforcement by the selection of proper processing rule. Although there are certain limitations in the mechanical performance of contemporary AMNCs, but in the future, more search on hybriding processing strategies and development of existing and new processing route for the fabrication of hybrid AMNCs to enhance
Sir,
the
okay,
properties of
stop,
the
sir,
AMNC.
please.
Okay.
Sir, have you compared any properties with the micro and nanoparticles for presentation?
Okay, sir.
Have you shown any slides regarding comparison of micro and nanoparticles while
No, sir,
performing
I have not prepared the mechanical properties.
So while you
Sir, just I have reviewed the properties regarding the.
compare the disadvantages of microparticles, you should what is called investigate what are the advantages of nanoparticles over microparticles by comparing. So many comparisons are available in literatures. Then it will be a better study. Okay.
Okay, sir. I agree.
Whether only one question: whether the nanoparticle will act as a filler or reinforcement?
Sir, nanoparticle act as a reinforcement.
Then reinforcement. Then what is the difference between filler and reinforcement, sir?
Sir, sorry, sir. It can be.
Okay. Okay, sir. No problem.
Thank you, sir.
Sir, Nadakumar, sir, we can call next one, sir. Yes.
Thank you, Mandeep Singh, sir. You can disconnect
Okay.
your presentation. Next, Vijay Bhubadi, sir, is arrived. Suresh Babu, sir. Shiva Bhaskar Rao, sir. Haridasan, sir. Haridasan, sir, is there? Haridasan, sir. Unmute yourself, sir. Sir, unmute yourself, sir. Haridasan, sir, unmute yourself. Ah, yes, sir. Please,
Okay,
please
okay.
carry on, sir.
There was some problem with my audio. Sorry.
No problem, sir. No problem, sir.
Good
Can you share your
afternoon.
screen, sir? Share
Okay.
your screen, sir.
Share. Okay. 1 minute. So, is it okay? Uh, shall I put it in the slideshow?
Yes, sir.
Okay.
Share screen, sir.
Share screen.
Present now screen is there, sir. Bottom right.
Bottom right. Okay.
Before presenting, you open the slide, sir.
Okay. 1 minute. I'm just struggling with locating this. Where it is, I'm not getting the share. Present now is there. Is that okay? Let me see.
Present now, sir.
Present now. Is it
Present
that
now.
one? Okay.
Yes, sir. I think we can. You just see you just practice yourself, sir. I will call another audience because time is up.
Okay.
Just practice yourself with your
Okay.
colleague, sir. Please, sir.
Oh,
I am calling another participant.
okay.
Mr. Sabrina. Mr. Sabrina, sir, is there? Mr. Sabrina is there? Mr. Sundar Selvin, sir, is there? Sundar Selvin, sir, is there? Mr. Hemalata, madam, is there? Mrs. Hemalata, madam? Sivasankar Rao? Shiva Bhaskar Rao. Shiva
Hello.
Bhaskar Rao. Yes, sir.
Yes, sir. Srivaskar Rao is present, sir.
Yes, sir. Are you available, sir? Shall we? Can you present, sir?
Yes, sir.
Please, sir. Carry on. Can you present your screen, sir? Shiva Bhaskar Rao?
Now this screen is visible to you, sir.
No, sir, not yet, sir. Yes, sir.
Yes, sir.
It started. See. Yes, sir. Please, sir. Carry
Yes,
on,
sir.
sir. Yes, sir. Carry on, sir. Please.
Good afternoon. Hello. Is this my voice is audible to you, sir?
Yes, sir. Yes.
Okay. Good afternoon to all of you. Myself, Srivaskar Rao Devreddy. Here I am presenting my research paper on experimental investigation of physical and mechanical behavior of broom grass root and glass fiber reinforced hybrid composites. Presently, I'm working as an assistant professor in Department of Mechanical Engineering, Science College of Engineering and Technology, Chirala, which is located in Andhra Pradesh. Now, this is the overview of my presentation. This presentation consisting of this introduction, literature review, objectives, materials and methods, results and discussion, and finally conclusion. All of you know what is this composite material, which consisting of the two phases. One is reinforcement and another one is matrix. Coming to this reinforcement phase, these are maybe synthetic or natural fibers. Our main focus we are nowadays due to the environmental concern. Many researchers are working on these natural fiber reinforced composites. The slides represents these different natural fiber reinforced available in the nature. Examples are jute, banana, hemp, wood, sisal, honeyqueen, coir, canaf, bagasse, rami, flax, bamboo, rice husk, grass, date palm. So many natural fibers are available in the literature. And this slide represents the classification of these different natural fiber reinforced natural fibers based on the bast, leaf, seed, fruit, wood, and grass. These natural fibers are used in mainly in automobile applications and household applications. The slides represents the components which are manufactured by the natural fibers with polymer matrix composites. Out of these natural fibers, we are selected in our research work. Broom grass root fiber is one of the reinforcement material because this broom grass root is available in countries like Bangladesh, Nepal, India, China, and Thailand, which possess the high aspect ratio, high toughness as compared to the other natural fibers. So we are selected this broom grass root as a one of the reinforcement material to fabricate the composite. The main properties which are considered to select the broom grass root is low elongation at break, low density, high specific stiffness, and strength as compared to the other natural fibers. The main objective of this present work is fabricate the different set of broom grass root and glass fiber reinforced polyester composites to study the physical and mechanical properties, such as in physical properties we are studied the density, water absorption, tensile properties such as tensile strength and modulus, impact energy, and hardness of the composite materials were studied. Another objective is what is the effect of this glass fiber content on these properties also calculated. Coming to the materials which are selected to make the composite, polyester is a matrix material we have selected. These polyester and corresponding catalyst and accelerator are purchased from this ECMAS Resin Private Limited, Hyderabad. The density of this polyester is having the low density as compared to the epoxy, that is 1.13 gram per centimeter cube. And broom grass root is selected as in the particulate form. Initially, the broom grass is collected from the local sources and which is washed with clean water, and it is making into the powder form. In a particulate form, we are making this broom grass root. And another one is glass fiber mat is we are selected as another reinforcement material. By using these two reinforcement and polyester matrix, the composite is fabricated. The composite is fabricated by this hand lap technique with followed by light compression molding. For curing this polyester, the catalyst and accelerator were mixed with 1.5 weight percentage and 1.5 weight percentage of accelerator. After mixing these polyester with this catalyst and accelerator, the broom grass root particulate is added into the polyester resin, and the glass fiber was placed in the layer form, layer by layer. By using this hand lap technique, the composite is fabricated. Initially, the epoxy is applied over the mold and place these glass fiber mat in such a way that to get the 4 mm thickness, we fabricated this composite. The details of these composite materials fabricated in the present work is shown in this table. Total 9 set of composites were fabricated. The first set is neat polyester resin without any reinforcement material, and second set onwards, the broom grass root particulate form was increased gradually with 5, 10, 15, 20, and another sets are with addition of glass fiber and without addition of these glass fiber, the mechanical and physical properties were studied. Total 9 set of composites were shown in this table. These are the composite fabricated by using this hand lab technique.
Sir, 5 minutes it's allowed for presentation, sir. Please.
Okay. Yes, sir. Yes, sir.
Go to you are wasted your time. You are giving introduction and other applications. Directly go to result and discussion.
Yes,
Conclude
sir.
because other participants are waiting.
Yes, sir. 2 minutes it will complete, sir. Yes, sir.
Please.
These are the fabricated composites with different percentages of the broom grass root and glass fiber. Next, coming to this characterization, density and void content were calculated. The theoretical density was calculated by this equation 1, which is written by Brotman and Agarwal. And experimental density is calculated by this Archimedes principle. The water absorption of the composites were performed as per ASTM standard 57098 standard. The difference between the specimen's weight before immersion and after immersion was taken and calculated by using this formula. Tensile test was conducted on UTM with ASTM standard D638, and impact energy is performed on Charpy impact tester with standard of ASTM D256. Brenner hardness tester was measured by using this Brenner hardness tester by using this formula. Coming to the results and discussion, theoretical density, experimental density was shown in this table. The differences between these two is giving the calculate the volume of the void content. If you observe this void content gradually by increasing the fiber content, the void content of these composites are increases. Water absorption of the composites also increases with respect to the immersion time. The maximum water absorption of the composite was observed for the composite which is having the TS8, which is broom grass root 28% without any glass fiber. Tensile strength of the composite. Here in tensile test, we are calculated the tensile modulus and tensile strength. Initially, the neat polyester is having the tensile strength of 30.28 MPa, and tensile modulus of 1.48 GPa was found. When we are adding this reinforcement phase, gradually the tensile strength and tensile modulus both are increases, and the maximum tensile strength is found 68.5 megapascal, and the tensile modulus is increases up to 2.97 GPa at 15.8% of broom grass root and 5.8% of glass fiber. That is the composite specimen designated with TS7, which is having the more tensile strength and modulus as compared to the other specimens. Impact energy is gradually increases with respect to the fiber loading. The maximum impact energy is found 3.5 joules. Similarly, the Brenner hardness test is Brenner hardness is also increases. The maximum hardness is found 97.94 Brenner hardness number at 15.8% of broom grass root and 5.8% of
Kindly
Brenner
conclude yourself.
glass fiber.
Sir, kindly conclude yourself. You are receiving the time, please.
These are the conclusions. The void percentages increases. The maximum void water absorption is found 8.99%, and the maximum tensile strength is 68.5 megapascal, and the maximum tensile modulus is 2.97 gigapascal, and the hardness and impact energy values are found 97.94 Brenner hardness number and 3.5 joules. Compared to this neat polyester, by adding these broom grass root and the glass fiber will gives the better values as compared to the neat polyester and only when we are added this broom grass, it will also having some less impact on these properties. Combination of these glass fiber and broom grass trees gives the maximum um, properties as compared to the other two. Thank you for this. These are the references. Thank you.
Thank you, sir.
Actually, you have fabricated hybrid glass broom grass fiber,
Yes, sir.
and you have not shown any microstructure, because by seeing microstructure only we can confirm the presence of fiber and other glass fiber. And is there any uniform distribution or pull out fiber pull out are available?
Yes,
So
sir.
you have missed the part. Main part is, so you
tensile
are
testing.
you
Yes,
are
sir.
doing material science na, without microstructure we cannot do anything. So the major part is missing in the presentation. So tensile, flexural, these are all experimental work. By seeing microstructure, we can give your comments, and you should prove yourself as a presence of glass and other particles in your fabricated specimen. So okay, so we can call the next one.
Okay.
Okay, sir. Thank you, sir. Shall we call next participant?
Yes, sir.
Mr. Vijay Bubri, sir, is there? Suresh Babu, Sivabaskar, Haridasan, sir, are you ready, sir? Sir, unmute yourself, sir. Haridasan, sir. Sir, unmute yourself. Haridasan, sir. Sir, it's not audible. Okay, we will call next participant. Mr. Sundar Selvin, sir, is there? Yamalata, madam.
Hello, I am audible now, sir.
Yes, sir.
Okay.
Are you able to present, sir?
I am able to present.
Okay.
Is it okay, sir? Visible now? Hello.
Sir, you can proceed, sir.
I am VP Haridasan. Good afternoon to all attending the online presentation. My paper is on the response surface modeling and parameter optimization of detonation spraying with enhanced coating performance. Actually, detonation spraying, a little word about detonation will be required, because it is not
Sir,
a
you
common.
can share your slides, sir, please.
It is not coming, sir?
Yes, sir.
Oh, 1 minute. But it is showing here as sharing. Stop sharing, it is showing. So why it is? Sir, it is showing as being shared. Sharing a window, it is showing. Shall I, 1 minute, then let me. Now, sir?
No, sir, it's not seen, sir.
I don't know why it is not.
Okay, sir, you'll be ready with the slides, sir. We will call
Okay.
next participant.
Okay, right.
Next, Sundar Selvin, sir. Kamalata, madam. I think two more audiences. I think Radhika Premnath, madam. Are you presenting, madam? Radhika, madam.
No, sir.
Vijaya, madam.
I'm a
Oh, you are
listener.
audience. You are listener. Vijaya, madam. You are listener. Vijaya, madam. Okay. I think everybody presented nicely. I think, sir, Rajmohan, sir.
Yes, sir, please, sir.
Sir, I think Haridasan sir is having some trouble.
No
I
problem,
think
sir.
there are two listeners, and then Mandeep Singh sir and Siva Bhaskar Rao sir, and then others are also presented very nicely. I think, shall we conclude, sir?
Yes, sir, we can conclude, sir, please.
Okay, sir. I think, dear participant, it is high time with you for this wonderful afternoon. I think you post your feedback in the slide ICMSD.org, okay, for having participation certificate. Okay, okay. I think Hariharan sir is back. So shall we wait for a few minutes, sir, for Hariharan sir? Rajmohan sir?
Yes, sir. Okay.
Okay, sir. Hariharan sir, are you ready? Hariharan sir? Hariharan sir? Hariharan sir? Okay, sir is having a network problem. I think it is online. I don't know what to do. Sir Hariharan sir, are you ready, sir? So kindly
Okay, sir.
unmute yourself, sir.
Sir, okay, we can conclude, sir. No problem.
Okay, sir.
Actually,
He's having some trouble because nobody is there.
yeah.
Okay, sir.
Mm.
Sir, concluding remark from you, sir, please, sir.
So, first of all, I thank to management and the principal for giving wonderful opportunity for chairperson in this AICT sponsored conference, and also I thank to coordinators Nandakumar and other Shanmugasundram sir for giving opportunity to share with this section. So thank you one and all. Thank you, sir. Please.
Thank you, sir. Thank you.
Thank you,
Thanks
sir.
a lot, sir.
Shall we close, sir?